Welcome everyone. Today we are going to see a very basic law of physics known as the Ohm's law. So we will study about this Ohm's law and we will understand what the law states and what are all the practical applications, then the limitations of this law. Okay, so let's start. Basically, in books we have studied this law, but we don't basically understand what is the use of this law or what the law is stating. So today we will see in depth what actually Ohm's law means. This law is the relationship between the current, voltage and the resistance for a given circuit. So what does this mean? It is like the current, voltage and resistance are the quantities which are interrelated with each other. Okay, as you are aware that if a circuit is not having any voltage applied across it, there won't be any current flow through the circuit. Same way, the resistance also will oppose the flow of the current. So these three are the quantities which basically present in the given circuit. So how they are interrelated or how we can understand the relationship between the current, voltage and the resistance. So for this, one German physicist known as George Simon Ohm came up with a law, and later on it was termed as a Ohm's law as per his name. So we will see what is the Ohm's law first of all, and then we will go into the details. This Ohm's law states that the current denoted by letter I through a conductor between the 2 points is directly proportional to the voltage V applied across the 2 points, provided all the physical conditions and the temperature remains constant. So what does this mean? Let's suppose I have a conductor. Let's suppose a copper cable. So for that copper cable, I'm just providing a voltage source or connecting a voltage source. Okay. So when the battery is turned on or the voltage source is turned on, the current through that particular copper wire will be directly proportional to my voltage or the potential difference I am applying. Okay. For this, there are some conditions like temperature should remain constant. Okay. So in terms of mathematical terms, this law we can it can be termed like I will be directly proportional to V, as we have mentioned here. The current flowing through the circuit will be directly proportional to the voltage applied across this conductor. Okay, or it can be vice versa. Now to remove the proportionality constant, we have introduced a term called the resistance. Okay, so then the voltage will equal to the current multiply the resistance value. Okay, or we can calculate the current or we can calculate the resistance. So this law will help us to understand how voltage, current and resistance are interdependent. Okay, and how to calculate the values based on the parameters. So this is what the statement of this Ohm's law. Okay, so here you can see one picture. It's kind of a real world scenario we can consider this. So let's suppose resistance through which some current is flowing, so denoted by this like amperes. Basically these are the units for the quantities. Voltage is denoted by volts, and ampere denoted or the current denoted by the ampere, and the resistance denoted by the ohm. So when you like turn on the power source or the battery, then there will be some current flow through the circuit. So this resistance will oppose the flow of current. So for this calculation, the Ohm's law will help us to understand how much the current will flow through a particular circuit. Okay. So next we are going to see basic a very famous triangle. So this will help us to remember the relationship. So how we are going to remember this triangle? So basically it is having three parts. One is voltage denoted by V, then the current denoted by I, and the resistance of the circuit denoted by the R. Okay, how this will going to help us to understand the relationship is, let's suppose we want to calculate the voltage. Okay, so voltage relationship can be calculated just by hiding this term V. So the remaining two term will give us the voltage value. Same way we can calculate the I and the R as per the this relationship. So we can calculate the current by just dividing the voltage by the resistance value. So we can get the current. In same way, the voltage and the resistance can be calculated. Okay, so this is a very simple way to remember the Ohm's law. So V, I, and R, kind of a three quadrants. Then we can remember the Ohm's law very easily with this. So now, as we have seen the Ohm's law, there are some limitations of this Ohm's law also. So the Ohm's law can be applied to a particular circuits. So the first limitation is this law cannot be applied to unilateral networks. Okay. First, we should understand what is meant by unilateral network. So unilateral network, we will understand with the help of a diagram. So let's suppose this is my unilateral element. Basically, this network is nothing but a circuit which is having some unilateral elements. So this network can have a unilateral elements like the diode, transistors, etc. So basically, the name itself give the details like unilateral means it is having only one direction. Okay, uni means only one direction. So these elements can only conduct in only one direction. Let's suppose I'm using a unilateral element, let's suppose a diode. If I just bias the diode, if I just give the input to the diode, then the diode will conduct only in this way. Okay, as the property of the diode, it can conduct only in one way, not in the other. So this case will not be possible in case of a single diode. So there will be current flow in one direction, other direction it will not be possible. So these kind of circuits will not obey the Ohm's law. Okay, same way it goes for the transistor. So unilateral networks will not obey the Ohm's law. The next one will be the nonlinear elements or the circuits which is having a nonlinear elements. Let's suppose consider example like a diode or a transistor. So basically, these nonlinear elements will not have a linear characteristics between the applied voltage or the input and the current flowing through the devices. So if you see, there is one characteristics. This is called a nonlinear characteristics, where the input and the voltage input and the current flowing through it is not a linear. So this kind of circuits also will not obey the Ohm's law. Okay. So next we are going to see some applications. Basically, we have studied the Ohm's law. Even there are some applications we know which are used in daily use. Okay, so I'm going to consider only some use cases which we know practically or which we use daily. So the first application is the fan speed control. How the Ohm's law will help us to directly control the fan speed. So you have seen this kind of device which usually we use as a fan regulator. Okay, so it's nothing but a rotary switch which will have some positions. When we switch from one position to other position, it will be the fan speed will get controlled. Either it will increase if you go by this way or it will decrease in the anti-clockwise direction. This device will have a resistive network inside it. Okay, so the resistive network, what it will do is it will pass a certain current at the output of this and it will go to the fan, okay, or the motor. So the fan speed can be controlled by just having a arrangement of the basic resistors. Okay, so for calculation of these resistance values, we will use the Ohm's law. Okay, so the Ohm's law will be used to calculate the resistance values, and based on this, the circuit will be designed so that Ohm's law can be used for this particular application. Now moving on to next application is the electric heater. Basically, this electric heater is nothing but a device which will work on the electrical supply. So this electrical energy it will convert into a heat. Okay, so basically it will have a resistive network. When you apply input to this device, what it will do is it will convert that into a heat. So that heat will be based on the amount of current you are passing through the resistors. So here also the resistance calculation or the values for the resistance can be calculated basically by using the Ohm's law. So this is one of the example. So next one is the electric iron and kettles. So these also will be working on the Ohm's law. So basically all are having same electrical resistance. So that resistance calculation will be done with the help of the Ohm's law. So one more interesting application is the fuse selection. Basically we know fuse. We have the understanding about what is meant by a fuse and how, like why the fuse is used. Basically the fuse is used in the household application for it kind of protection device which will protect the electric equipments or the appliances from high current. Okay, so for this fuse selection also we will going to use the Ohm's law to calculate the amount of current it has to carry. If a certain threshold is reached, the fuse will get blown so that the appliances which are connected up after the fuses will not be subjected to high electrical current. Okay, so for this fuse selection also we will be using the Ohm's law. Okay, so this was all about the Ohm's law, its limitation and its applications. So thank you guys. Thank you. Hope you liked my video. Thank you.